Welcome! In this series of videos, we will look at software add-ons for the PowerBasic Windows compiler. Today we will look again at using the MyLotoGrid custom grid without the use of SQL Tools or SQL Server to speed up your application development. This was our application at the end of the last video. We have an application created using PowerBasic Windows, and this is displaying a grid on screen which is a MyLotoGrid. Both the data and the configuration of the grid are coming from static files. And in the grid we can quite happily go down and update records. Each updated record shows a green background to the cell to indicate that it has been updated, but we have yet to save any changes to the database. That's what we're going to be doing today. We've already done some preparation for this, in that when the application initially loads, the Save Changes button on the toolbar is greyed out. Having made some changes to this grid, on this Data tab, the Save Changes button has been automatically enabled. However, when we switch to the Departments tab, although we haven't made any changes to this worksheet, the Save Changes button is still enabled. So what we're going to do first is we're going to put some more logic into our event handler for the grid control to allow us to detect when the user clicks on a different tab. So the sheet has actually changed and we should be able to pick up the fact that this has occurred. So let's have a look at the event handler, the callback function of the dialog. In the callback function there is a notify section. This is where all the events on the grid are actually sent to. And here is our notify section. And within this we are specifying the grid on the screen. In this particular application there is only one grid. And we're picking up the events occurring on that grid. For example, the right click menu, the fact that a cell has altered, and the clicking of a user button. We're going to add a new event here to pick up the fact that the user has selected a different sheet. And our event for that is the sheet select. Now when this is triggered, it means the user has selected a different sheet. So we can pick up two pieces of information. We can pick up the sheet number that we are leaving and the sheet number on which we are arriving. This is very useful, as you may in some of your applications have a need to give access to a particular sheet only to a selection of users. This way you can detect that the user has attempted to click on another sheet. You can then check the permissions to see if they're allowed to do so, and then if they are not, you can put the grid back to the original sheet and display a message to the user. Now this will involve setting up two new variables here, so we'll just go up to the top of our event handler and we'll put our new variables in. So there are our two new variables, my old sheet and my new sheet. I've added a third new variable, and we're going to be using this to work out the number of records on the grid that have actually been amended. So here we are in the event. The user has clicked on another sheet and it has been selected. So the new sheet we're going to will be this sheet here. So as we know, we start the application off displaying sheet number 1. So if the user clicks on the other sheet, we know in this particular application there are only two sheets. Therefore the sheet selected must be number 2. It's quite possible in your application you may have more than two sheets. But the code in here will pick up the old sheet number you're leaving and the new sheet number you're arriving on. So having clicked on the new sheet, our task is then to figure out, have there been any changes made to this particular sheet on the grid? So we're going to use one of the inbuilt functions to our MyLotoGrid resources library. This function will quite easily return the number of changed records on that sheet. It takes merely one parameter, which is the grid handle. And it will count the changes on the currently selected sheet, which will be the new one the user's actually picked up. So if there are any changes, what we'll want to do is we will want to set the state of the toolbar save icon. So if changes is greater than 0, then we know there are unsaved changes on the sheet, and we will set the main toolbar to enabled. If there are no changes, the value of long changes will be 0, and we can set it to be marked as grayed out, disabled. So if we try that code now, we'll see our application starts off with the Save Changes toolbar icon as grayed out. If we switch to the other sheet, the department sheet, it's still grayed out. Now we can't make any changes to the second sheet because we've configured it to be read only. But on our first sheet, we can go in and make changes. So if we change one of the records, we'll see that the toolbar button has indeed changed to be enabled. If we now switch to the other sheet, we'll see that the toolbar is automatically disabled for the save changes. So the application now realizes the sheet which we're now viewing has had no changes made on it. If we go back to the data sheet, it will be re-enabled because the application realizes there was at least one record on the sheet which has been updated. So this controls the clickability of the Save Changes button. There's no point letting the user click on the Save Changes if there is indeed nothing to save. So having achieved that, our next task is to actually attempt to save the data back to our flat text file. In our libraries at the beginning of the application, we have commented out the SQL Tools library, and we've commented in the generic CDF functions library. With these changes, it allows us to read and write from flat text files in a CDF config folder. So all the data when our application initially loads is coming from this file here, spr get user list. Now this file itself contains all the columns. Now in our last video we added a skills column. Now if we were amending this in a database, we would want to add the skills column into the database as a new column. Since we're handling all our data coming from this file, we're going to have to add a skills column to this file. So we can quite easily do this by adding to the file itself. So we will add to our header the name of the column, and we'll add some data columns to each of the records. And we'll copy that down to every record in the file. This is of course much easier to do on a SQL Server database. I can thoroughly recommend the use of SQL Tools with any ODBC compliant database. In this case I normally use SQL Server. So now that we've added the data to our flat text file, if we save that now, when we do our updates, it gives us somewhere to do the update to. For example, of this first record, the last column is skills. A 0 would mean the box is unticked, and a 1 would mean the box is ticked. So now that we've updated our raw data file, let's look at the code for see what we can update in there. In the event handler is code to handle every event on the dialog. The user is about to click on the save button on the toolbar. So if we go down to the command section, the command section does not have a great deal in it at the moment, but we're going to create a new event to handle the clicking on the save button. The identifier for the save button is ID save. So if the user does click on that save button, any code in here will be executed. The user of course could have changed several records on the grid before clicking the save button. They don't have to click the save for each individual record. They could do many records and then click the save button. So the task of this routine will be to save any record that has been amended back to the flat text file. So we don't want the user doing anything else while it's actually doing the saving. Therefore we're going to set the global long refreshing to true. And then once the routine is finished, we can turn that back to false. Just in case there's a problem in saving any of our records to the database, we want to keep track of the number which failed to save. So we'll create a local variable to keep track of that. And we'll call that long records failed validation. And we'll initially set it to value of 0. So we'll create the variable for that in a moment, but let's put some more structure in. We're going to create a new function called save the changes, which will save all the changes on the sheet of our selected grid. So we'll pass it two parameters, an input parameter, which is the grid handle, and an output parameter, which is going to return the number of records which failed validation, the number that failed to save to the database. And we can detect that and give the user a message on screen to say that something has or hasn't saved to the database. So if the number of records is greater than 0, then some records have not been saved, and we'll display an error message to the user to let them know it was only a partial saving. And if all the records were actually saved successfully, then we can effectively change the state of the toolbar to say that everything has been saved successfully. So we'll change the state so that the Save button is greyed out. So let's create this local variable, and then we'll move on to create our Save the Changes function. So there's our new variable created. We'll now go down and we'll create our new function. So here's the routine that's going to be saving the changes. We're passing in our grid handle, and we're going to be passing back the number of records that failed validation, if there were any. So there's a few local variables we'll want to create. So we created some local variables we'll need during the run of this function. So as this particular routine could be used for many different types of grids, the first thing we'll need to do before we do anything else to work out is how big the grid actually is. So we have some inbuilt functions to our MyLittleGrid library that can work out how many rows and how many columns are actually in our grid. So having determined how large the grid is, we can now capture the whole grid into an array. There's a useful function within the MyLittleGrid library which allows you to pass it two parameters, one being the grid handle and the second being the array into which you want to store all the data that exists within that grid. So now that we've got that data, we can now go through the array to look to see if any of them actually needs to be saved. So in the previous video, we had actually shown we could actually update the grid to mark a specific number against each record, and we were using this to mark a record as needing to be updated. So we're now going to sweep through the array, and we're going to get back that record number to see if it needs saved or not. We're going to call another function within the MyLittleGrid library, the getRowRecordNumber. This will pull back a value, which we're going to interpret as whether it needs saved or not. And if it does equal the constant we're using for the fact it's been updated, we'll know it needs to be saved back to the database, or in this case, the flat text file. So the logic so far is quite generic. It doesn't really matter what kind of grid it is, or the content of the data. But we have identified that a specific row on the grid needs to be saved to the database. This is where we want to put in another function call to actually save the specific record to the database. Now I'm thinking ahead here because what we'll probably want to do in a later video is we'll want to add data that has never existed to either the database or the flat text file. What we're doing here is updating existing records in the database. So I'm going to use a return value from the save record function, which will be effectively the unique reference to the row. Now at the moment we're just going to get it to return a true or false, but in future videos we'll update it to return actually a number. If it returns 0, then no row has been updated. If it returns a number greater than 0, then something has been updated and the value will be the unique reference to the record itself. But our save record function, which we'll be writing in a moment, takes 4 parameters: the grid handle, the array, the element within the array, and another variable we'll use to store any error messages. So since we'll be returning a true or false, if the value of rule ID is false, then we were unable to save the record to the database. So we'll put a message box to the user to say there's an error saving. Now this is fairly unlikely, but always a possibility. We will then increment our variable to say the number of records that failed validation, which gets passed back to the calling routine. In the event that we'd actually do manage to save this particular record to the database, there are 2 things we need to do. We need to change the record number on the grid to say that this record is no longer needing to be saved. Secondly, we want to remove the highlighting on the cell to show that this particular row has now been saved to the database. So for the first part, we'll be using a function within the MyLittleGrid library itself to set the row record number, and we're putting a constant in there which basically is marking it as being saved. Our second call is to remove the highlighting. We're going to be using another pre-built function in the MyLittleGrid libraries that we have ourselves created to unmark the entire grid row, so any cell within that row will have its highlighting removed. It of course takes only 2 parameters, the grid handle and the row. So having done that, we'll now have to create our save record function. So that's another new function we'll have to create. Now the save record function will have to be specific to the particular grid and tab we're actually looking at updating. In your application, you may have several grids and many tabs. So here we have the save record function, which takes the 4 parameters: the grid handle, the reference to the array containing the data, the row number, and a passback variable to contain any error that we discover. And there are a number of variables we're going to be using in here, regardless of which tab or grid we're actually saving. So the specific information in this function will be the name of the form, the name of the grid, and the name of the tab. And as we've done before, we will get the unique handles to this in the user-defined type, using our pre-built functions to get the form number, the grid number, and the tab number. Having got that far, our next stage is to work out how many columns are actually in our grid. And we can use our getColumnsInGrid function to pull that back quite happily. So in order to make this function as easy to use as possible, I wanted it to be able to work out how many columns are on the grid, what the result name of the column, the internal name of each of the columns were, so that it could effectively build up a parameter list. And if we're using SQL as the database of our choice, then it can then pass a list of named parameters to a SQL store procedure to update the database. And the first parameter on the list is going to be the one we're going to be using our where clause for, the one that will uniquely identify the record that needs updated. So how we do this in code here is we're going to create an array to hold the columns. These are the column IDs. This section of code is actually going to look at the grid itself and going to pull back the columns in the UDT using a pre-built function. Then, having got that far, we'll then want to pull back the data that's in our str work array. So we know how many columns there are, so for each column in the array we want to pick up the actual value in the cell. We're using the escape apostrophe function to handle single quotes. SQL Server uses a single quote as a delimiter of a string. So if any of the values in our grid have a single quote in them, this would cause the SQL to fail. So we use the escape apostrophe function to replace a single quote with a double quote, and SQL Server can handle that quite nicely. We know there's a possibility in some of your grids that there will indeed be checkboxes. And the checkbox in a MyAutoGrid has three possible values. It will either be blank, in which case it's not ticked, it will have a 1 in it, in which case it has been ticked, or it will have a $1. So the easy way to actually test this is to use a getProperty call to check to see if the cell we're looking at is indeed a checkbox. So the getProperty one is one of our functions in our library. We have defined some columns as checkboxes. If that's ticked, then this would return true. We can then call the MLG getChecked function, which is a library function within MyAutoGrid itself, to determine whether it is actually checked or not. If it's true, then we set our value to 1. If it's false, then we set our value to 0. So now we've got that, we can then form up the SQL parameters. So since we wish to use the internal name, which is the result name, we can use another getProperty to pull back the result name of that particular value, given the handle will be turned earlier into our array. And finally, we only want the columns that are actually in use. So any column which returns unused, we can ignore. And we're building up our SQL parameters as in the @, the name of the field, which is the result name, and equals, and the value we got back from the grid. And we will do that for each column. And having got that, we will trim off the last comma. And then we have our SQL, the name of our database store procedure, if we're using a database, and our parameters list. So having got that, our next task would be to run the SQL and check to see if it's actually saved or not. Now in our code, we won't be saving to a database, we will be saving to a flat file. But our run SQL function will work quite happily either way. So that's most of the code actually created. However, we're going to be passing to this run SQL function a store procedure that it won't be aware of. So normally if we did that, it would attempt to actually access a file name based on the name of the store procedure and the parameters list. Now such a file will not exist, so we'll need to put some extra code in our cdef functions. So if we open our cdef functions library up and we have a look at run SQL, and here is all the code to handle these calls. The first part splits up the parameters and puts them into an array, and the next part further down is to handle specific SQL calls. Now I have already created one to handle the save get user list. it works out the file name as sprget_userlist_cfg, which is the file from where all our data came from to populate the grid in the first place. And that calls a new function called updateTableFile. It takes three parameters: the file name, which we've just defined, the array of parameters, and a handle coming back, which is to contain any error. So if we have a look at the updateTableFile, this quite straightforwardly takes the entire config file and loads it into an array. It then works out the headers, takes the field name and the very first parameter, which is our where clause. It will then search through the entire array to see if it can find the value that we have specified in the field. If it finds that, it will then call the updateArray function, which we created in a previous video. And having updated the array successfully, we can then dump that entire array back to the disk. So having got to the end of our save function, we'll then want to refresh our grid. And we can return true to the call-in function. So we try running our application now, and we update one of our records and click the save button. The background disappears to indicate the fact the file has been updated. So let's have a look at the raw text file to see what it looks like now. There is our file with our update timestamp. If we open the file up now, maximize it, we'll see on our very first record, the last column, which is our skills column, now contains a 1. So it has indeed updated the record. So if we run the application itself again, we'll see it comes up with it ticked. Now, one last change I want to make to the application is to do with the sorting. At the moment, if we tick our second record to say we've updated it, and we attempt to sort our grid on one of the fields, we'll see that the highlighting still remains on the second cell, despite the fact that the data which we did update has moved further down. So we want to put a check in here to make sure that any changes made to a grid are saved prior to any attempt by the user to resort the grid. So let's go back to our event handler. So in here, the event handler for the right-click menu. And one of the options is to do a sort on the grid. It will sort on the currently selected column in ascending order. So I want to put a little more logic in here to make it a little more intelligent. So the first thing we can do is we can determine are there any changes on this grid, using the count changes function we used earlier. If there are any changes, we can display a message box to the user to say that there are unsaved changes and they should save this worksheet before going any further. The other change I want to make is to make sure we don't actually sort the application on the primary column. The primary column for this particular grid is a numeric column. So I'm going to use another inbuilt function to get the grid position of the primary column. It takes our usual parameters, the form handle, the grid handle, the tab handle, and the grid itself. So if we're not on the primary column, we can go ahead and sort just the way we did before. Otherwise, we want to basically repopulate the grid from our source data. So just like we did when we loaded the grid initially, we're using the autopopulate function to generically populate our grid based on our SQL. So these two changes going in should allow us to handle these problems. So if we tick the skills for record number 2 and then resort the column, it will identify that there indeed are unsaved changes. To please save them before sorting. So we can save them and then it will allow us to resort. And if we attempt to resort on the ID column, our primary column, there'll be a short delay and it will reload all the data from the database. So if we change one of these other ones and then attempt to resort the first column, it will of course identify that we've made a change. So what we've achieved today is we've managed to take our grid updates and we've saved them back to the original flat text file. We've changed the toolbar so that the Save Changes button is only active when there is something to save. And we've amended our sorting function to ensure that there are no changes not yet saved back to the flat text file before we attempt to do a sort. So what we're going to do in our next video is we're going to allow a user to be able to search this grid by putting in some query parameters above the grid itself. But that's it for today. Thank you for watching.